Hello, Math 30. Welcome to Transformations Lesson 2, Horizontal and Vertical Translation Part 2. Just a reminder, we talked about from last day, so you would have learned horizontal and vertical, the H and K values that we're talking about in this bullet. Just to, or again, something that should be 100% clear is the two different ways of expressing the vertical translation. So if I have y equals x minus 3 squared plus 5, clearly we know that that graph is going to the right 3, and it's definitely going up 5. But you need to see that and be clear that we could take this 5 and put it over here, and if we did, it still is doing the same thing. That in this version, that this is still going to be right 3, and it's still going to be up 5, even though it looks now like, oh, well, I switched those up. That's not H. This is still H. Oops. This is still our H value, and this is still our K value. But as you can see, it can be written in two forms, and you need to be 100% clear and understand it. All right. It talks here about the difference in replacement and also what we talked about last day. Just want to make sure you're 100% clear on this mapping notation versus replacement notation. So I'm just going to start with an example, and I'd like you guys to follow along. If somebody says that, I'm just going to start right here. If somebody says what we really want to do is we really want to go, and I'm going to say this, we really want to go to the right 5. That's the statement. We want to take a function, go to the right 5 and down 2. So that's the translation. If you were to write the map of that, so you're going to map the point xy. So you're specifically talking about a point. So what you see is what you get. What does that do to the point xy when you talk about mapping notation? Well, xy, if you are going to the right 5, xy would get mapped to x plus 5, and y would get mapped to y minus 2. What you see is what you get. That's what mapping is about. You're mapping a point. Now I just put a little squiggly, but what if somebody says what we really want is we're now going to talk about y equals f at x, and being that we're talking about that, what would be the replacements in y equals f at x for us to do this same thing? Well, in terms of replacements, what you would do is you'd say, oh, x, y, the replacements for x and y in this notation would look like, well, x would get replaced with x would get replaced. In this case, if I want to go to the right 5, x would have to get replaced with x minus 5. And if I want to go to the to down 2, I would replace y with y minus 2. Now what would that look like finally in function notation? In function notation, it would look like y, whoopsie, it would look like y minus 2 is equal to, hold the phone here, hold the phone, we got to fix this. If I want to go down 2, this is what we got to think about. If I want to go down 2, I would replace y with y plus 2, right? Y plus 2. And when I go to my my graph and say, well, what would it look like in function notation? In function notation, therefore, we would have y plus 2 is equal to f at x minus 5, which, as we looked up top, could also be written as y equals f at x minus 2 minus 2. And that will go right, silly Mr. K, trying to make a video at the end of the day and making lots of mistakes. So y equals f at x minus 5 and minus 2. Okay, so that's a review of what we talked about last day. In example 1, we would like to write the replacements for x and y and describe. So I want you to complete example 1 and see how you do with that. Okay, Math 30. So in the very first one, if you tried, I just chose to write that function. I chose to write this as y minus 3 equals, shouldn't be x squared, it should be x to the 4th. So you could write it both ways, but regardless, the reason I chose to do that is really what has changed here. Well, if you write it in that manner, then y was really replaced with y minus 3, because that's what you need to see as the replacement strategy. And what does that do? It really moves it 3 up. I think you can see the 3 up right here, but in terms of the replacements, you want it to be y is replaced with y minus 3. If you look at the second one, at the heart of this function, x is right there, was replaced with x minus 1. So at the heart of this function, what's happened is that because we replaced it with x minus 1, there has been a horizontal translation of 1 unit right. In the next question, absolute value x is the function. Well, what's happened? Well, there's been two things. There's an x minus 6, and there's this 2 that's on the outside. Clearly, that's the h, right? This is the h value, and this is what's going on with k. So what were the replacements? Well, we've got, if I take that 2 to the other side, I've got y minus 2 is equal to absolute value, x minus 6. So therefore, y was replaced with y minus 2, and x was replaced with x minus 6. What does this do to the function? It moves it 6 right and 2 units up, okay? If I look at D, clearly, x was replaced with x plus 1. That results in a translation 1 unit left. So now in this question, we're now asked, well, how about we write the replacements for x and y, and then the equation of the image, y equals x squared after a horizontal translate 3 units right. Well, what's the replacement? If you want to go 3 units right, you're going to replace x with x minus 3. And now, well, if you want to build that function, change from x to x minus 3, and you now get a function x minus 3 squared. That's what they would like. In the next one, we want to take this function and move it 2 units up. Whoa, 2 units up, what does that mean to do? What's the replacement strategy? How do I translate that? Well, 2 units up would mean I should take y and replace it with y minus 2. Therefore, that's what my function will look like. Y minus 2 equals 10 to the x, or it might be y equals 10 to the x plus 2. What about a square root function that went 4 left and 3 down? Again, write the replacements for it. Well, the replacements would be x gets replaced with x plus 4 and y gets replaced with y plus 3. Therefore, y plus 3 equals the square root of x plus 4, or the multiple choice or wherever you see this might be y equals the square root of x plus 4 minus 3. All right, carry on. What does it look like in example 3? So what I'd like you to do here is take the time. First off, as you read it, remember that as it says there, the thick line is the transformation of the thin line. So that's the one that got moved. Write an equation to represent the thin line. So what the thick line. So look carefully, what's the basic function? Write the transformations, right? Write the replacements for it, and then write the equation, right? So for example, in the first one, right? If I just do the first one. If I do the first one with you, okay, horizontal translation. Well, what happened there? Look at what happened from the original graph to the thick one. Well, clearly you can say, well, it went 2 units right and it went 4 units down. Great. What does that mean in terms of a transformation? Well, it means that x must have become x plus 2 and y must have got replaced with y plus 4. That would do it. Now you go to the equation and you say, I've got y equals absolute value x, replace x with x minus 2 and y with y plus 4, and you get this function right here. But it could also be written like this, okay? So I would like you to continue that pattern with each of these pictures, taking a transform graph and writing the equation of the transformation, okay? All right, pause and come back and do it. Now we look at this graph. Haven't really done much with a reciprocal graph, but clearly the black line is moved right 1 and 2 units up. That would replace x with x minus 1 and y with y minus 2. Therefore, one possible equation would be y minus 2 equals 1 over x minus 1. C. In C, clearly this graph just moves straight 4 down. The only replacement would be y is replaced with y plus 4. Now notice they don't actually give you an equation. So you can't write the equation that your calculator would graph. They just called it y equals f at x. So you need to make sure that you maintain that, well, this is replacing y with y plus 4, but you need to have that f at x, right? You need to maintain that, all right? And lastly, we've got a parabola, and we know that this thing was moved 3 left and 4 up. So there's my replacements, x with x plus 3 and y with y minus 4. We put that into our equation and we end up with y minus 4 equals f at x plus 3. All right? Pause and complete 4. Oh, I hope you struggled a little bit through this. Okay. So just to share how this kind of happened, you're looking at this case. Well, what happened so that this graph goes through 16.7? And it specifically only says a vertical translation. So in this case, plug in 16 into your original question, right? That's what I'm saying right here. If you plug in 16 right there, what you're supposed to get out of that is the square root of 16 is clearly going to be 4. But you didn't get 4. When you plug 16 into this new graph, you got 7. So how did that happen? Well, clearly, if 16 gave you 7 instead of 4, clearly what must have happened is this thing must have been moved 3 units up because 16 doesn't give you 4 like it's supposed to, right? So therefore, what vertical translation? It must be 3 units up. In the second question, what horizontal translation would be applied to y equals square root x so that the translated image would go through 17.8? Okay, well, let's see. Normally, when you look at it, 8, the only place, if you go backwards, if you put 8, and I don't know if you understand what I'm saying, but here's your point, right? There is a horizontal translation. That number isn't what it's supposed to be. Obviously, in the transformed version, you got 17.8. If you put 8 in for y, what value of x should there normally be? Well, it should be 64. 64 should be the x value that normally gives you 8. Well, what happened? Well, the only way you can get 8 is by having the square root of 64. So therefore, this thing must have been moved 47 units to the left, right? Therefore, when we look at our function, x must have been replaced with x plus 47. And if I go back to this one, y must have been replaced with y minus 3. All right. So vertical translation up. It didn't say for us to write the equation. All right. Carry on and stay classy, Math 30-1.